It means clear to send.
Hmm.
In the previous class, I talked about that it is half duplex.
Right.
Which means at one time, either it can send or it can receive.
Right.
So before transmitting the data, device will send RTS frame.
Right.
Let us say this is my device. It need to interact with the AP.
Mm-hmm.
It will send RTS that okay, I am requesting you to send something. May I?
Mm-hmm.
So
Mm-hmm.
if there are some other communications which are going on, let us say, it will not respond for CTS, right? But if it is empty and it is okay, it will just reply with CTS. So this frame means it is confirming that, yeah, I am ready to receive the data. And post that, actual data will be transferred.
Mm-hmm.
Okay.
So it'll check if the channel is idle, right?
Right. It will just see that either for the communication, my channel is available or not. So end
Right.
device is named as station, right?
Right.
So every time station want to transmit a frame, it must perform the RTS or CTS exchange prior to any data transmission.
Okay. So it will check if the communication medium is idle or not, right? If it's idle,
That's
then it's going to send, right?
that's true. That's true.
Right. So it will, before sending the data, it will check for RTS and CTS, and then it will check if the channel is idle. Okay.
Right.
If the channel is idle, then they will send the data to the
It will
station will
transmit the data.
pass
Right.
the data to the access point. Okay.
Right.
And that, it's called delay mechanism too, right? Because they will
There is
see
a
if the
delay.
yeah,
Yes.
they will see if the channel is idle. The communication medium is idle for a few milliseconds.
But once
Then
it received the CTS, it can transmit because RTS and CTS is just confirming that channel is it is clear to send, as the name is saying, clear to send, right?
okay. So that's a delay mechanism too, right? It will see the channel is idle. If the channel is
That is
idle, then it will
CSS.
send the data.
Yeah, that is CSMA CA. Okay,
Yeah.
so that is one. That was a one way, but now when you receive CTS, no delay is required.
Uh-huh. Oh, that is one way. Delay mechanism
Right,
one way.
right.
Okay. So if you see if it is clear to send, then it will send it. There is no delay
It
mechanism.
will send. Correct.
Okay. So there's two things. One is RTA CTS, other one is delay mechanism. Is it?
Earlier it was delay also. Yes.
Okay. Okay. Thanks.
The
So
rest,
they're
have
using
you been
RTA
through the
CTS
whole
now.
class?
Yeah, are they using RTA CTS now or delay mechanism? What they use right now?
No. RTS CTS is enabled by default.
Okay. So they don't do delay mechanism.
Hmm.
So it's RTA CTS, is it? What they do
Right,
right now?
right.
Okay. Thank you.
Okay. What about 2.4, 5.2? Clear that parts?
Yeah. Number of cycles in of radio
That is
frequency gain per
frequency.
second.
Right,
Frequency inversely proportional to lambda. Lambda is inversely proportional to frequency, right? Okay.
right.
More number of cycles, more number of waves, you will have greater range and greater coverage. Less number of cycles, less coverage. And 2.4 hertz is measured in hertz, and 2.4 has got more number of wave cycles, so it will have more range coverage. Whereas 5.2 has got less number of cycles and less number of wave coverage and
Right.
range. Okay.
So what was that? That was frequency, what you were
Mhm.
describing. So let me tell you. Okay.
Yeah.
So just as a brief introduction, let us say these are the channels. One wave is going like this.
Mm-hmm.
So it is 2 cycle per second, which means 2 hertz.
Mm-hmm.
One wave is like this: 1, 2, 3, 4. How many
Mm-hmm.
cycle? 4 cycle per second means 4 hertz.
Mm-hmm.
One can be having like this, maybe 8. So it will say 8 cycle per second, 8 hertz. Frequency
Mm-hmm.
determine how often a signal is seen. It is
Mm-hmm.
cycle per second or hertz.
Mm-hmm.
And low frequency means higher distance.
Higher
Travel,
range, higher range coverage.
travel further.
Mm.
Okay.
Okay.
We discussed about this point. Then we talked about the wavelength also, right?
Right, right.
What is wavelength? Like if there is such kind of wave, this is
Right.
wavelength. But if
Mhm.
there is such kind of wave, this is wavelength.
Right. Distance between two consecutive points.
Right. If such is a wave, this is wavelength.
Right,
So
right.
the signal generated in the transmitter is sent to the antenna, and that antenna will create a frequency, and the size of the cycle pattern is called wavelength. Right.
Mm.
Then we discussed the third point. What was that? Amplitude. Remember?
Yeah. Signal strength. And this is strength of the signal.
Correct. So let us say if this is a wave, so this is the amplitude. If this is a wave, this is the amplitude. But if we
Mhm.
have a good wave, good signal strength, this is the amplitude. So
Mhm.
this is our strength of the signal.
Mhm.
Amplitude represent the quantity of energy injected in the signal,
Mhm.
right?
The displacement of the waves across the equilibrium, right? Displacement of
Yeah,
the waves
yeah,
across the equilibrium. Okay.
yeah. Any doubt in this?
No problem.
Then 2.4, 5.2 we discussed. Any doubt in that?
No problem.
No problem. Good.
Okay.
Then we talked about RSSI and SNR. Any doubt in
Yeah.
that?
No problem. No problem.
Then various standards like B, G, A, N, A, C, A, X.
No doubt. No doubt. No doubt.
Fine. Then we
Okay.
talk about the channel overlapping like 1, 6, and 11. Why 1, 6, and 11 are there? I hope that is
Mm.
also clear.
Yes. Yes. No problem.
Fine. Let's now talk about next topic. Okay.
Mm.
Do let me know once you're able to see my slide. Are you
Okay.
able to?
Yeah. Yeah.
Fine. So we are discussing about wireless technology here.
Mm-hmm.
And as I told you in our previous class, Wi-Fi means
Mm-hmm.
wireless fidelity,
Mm.
right?
Mm.
Wi-Fi, one of the major fastest growing technology of all time, and it will be keep on growing. Okay,
Mhm.
lot of scope.
Okay.
Let me proceed. So here in this slide, if you see, I just attached a screenshot from our virtual WLC. You can
Mm-hmm.
see I am in the wireless. Under the
Mm-hmm.
wireless, I am into the 8.2A, and you can
Mm-hmm.
see ANACAX. Okay.
Mm-hmm. Mm-hmm.
So here I just went to the network, and in the
Mm-hmm.
network, you can see this page is shown.
Mm-hmm.
It is displaying like what kind of data rates it is able to equipped with 6
Mm-hmm.
Mbps. You can just put mandatory if you want that. Okay, your these data rates are mandatory. You can
Mm-hmm.
put some of them as the supported also. Supported
Mm-hmm.
means these are not mandatory but optional. If devices wanted to get on, these kind of data rates, they can. But again, let me tell you, let us say if there is your AP,
Mm-hmm.
okay, and it is transmitting the signal.
Mm-hmm.
As it will go further, the data rate will keep on decreasing, right?
Mm-hmm. Mm-hmm.
So if one of the client is here, maybe data rate will be much. If one of the client is here, maybe the data rate is not as equivalent to the client number one. Got
Mm-hmm.
this point?
Mm-hmm. Mm-hmm.
So let me tell you, there are one thing named as modulation.
Mm-hmm.
Modulation means what? what your wireless does, it
Mhm.
modifies something. What it modify? It modify the, maybe you can say, signal by amplitude, frequency, phase, or maybe combination of all, or maybe one of them
Mhm.
to encode the information. So modulation is what? It is, you can say it is a technique which is very crucial when transmitting the data over your wireless communication channel.
Mhm.
Okay.
Mhm.
So there are a lot of modulation techniques which are, getting in used from the starting to nowadays.
Mhm.
Let us say if you will go for 802.11a
Mhm.
and 802.11b, the modulation technique can be differs. Why? Because for B, the data rates is also differ. Let us say 1.2.5.5 or 11 Mbps is supported. Okay.
Mhm.
So for 1 or 2 Mbps, even there is a modulation technique named as DSSS.
Mhm.
Heard about it?
Yeah.
So this DSS means direct sequence spread spectrum.
Mhm.
Nowadays, actually, this is not so much popular, or maybe legacy one, I will say.
Mhm.
So this is a modulation technique used in your wireless communication system to
Mhm.
spread the signal over a wider frequency than the original data signal. Okay. So
Mhm.
DSS is designed to provide your improved resistance to the interference. Why? Because 2.4 in our previous class I talked about, right? In
Mhm.
2.4 is more prone to the like interference,
Mhm. Mhm.
right?
Mhm.
So making it particularly useful in those environment with your noise and interference, DSS modulation will be used.
Mhm.
Then there is one more name I will take again. It is also nowadays not so much popular. CCK,
Mhm.
complementary code keying.
Mhm.
Complementary code keying. This is again one of the, you can say, modulation technique which can provide 5.5 or 11 Mbps of, you know, data rate. Okay.
Mhm.
But nowadays, the popular one, what is that? That named is OFDM. You will hear these terms when you will, go in such of discussions, or when you will see configuration of your wireless
Mhm.
controller. So
Okay.
OFDM is the modulation technique that is really widely used in modern wireless communications,
Mhm.
even including your A, G, N, AC, AX,
Mhm.
4G LTE, 5G, or digital television broadcasting also use this modulation technique named
Uh-huh.
as orthogonal, then frequency division, multiplexing. Okay. Now, what happened is, as the time passed by, there
Mhm.
is, if you just, try to understand, like everything is AP based, right?
Mhm.
So earlier the antennas was the internal one only. No,
Mhm. Mhm.
but as the time passed by, there was the external antenna. This
Mhm.
can be the unidirectional,
Mhm. Mhm.
but unidirectional like the DD TV in earlier days. What was that?
Mhm.
The unidirectional antenna. But in case of AP, it is bidirectional,
Mhm.
right?
Mhm.
Now there are multiple antennas also come.
Mhm.
Getting my point?
Mhm.
When you have such a thing, it means you can approach to multiple receiver at same time. by dividing the high-speed data stream into multiple lower substreams onto a different carrier frequency. And these carriers are very carefully chosen to be, orthogonal to each other, meaning they should not interfere with one another, even when they are very closed space. So it enables the carrier to transmit simultaneously without causing the interference, which is really very significant advantage in case of wireless communication by providing you very high bandwidth. So OFDM, remember this term. It is the key technology in the modern wireless communication system, and it enables very reliable high-speed data transmission in the challenging environments. Okay.
Okay, so OFDM will increase data transmission rate, is it?
Sorry.
OSPM will increase the data transmission rate.
OFDM is the modulation technique. We are talking about modulation technique.
Okay.
So modulation means what? To change, or maybe to do some algorithms to for modifying your poor signal to the higher rates, like modifying its amplitude, frequency, or phases, or different parameters.
So it will change the frequency, the data transfer rate. It will change, is it?
No, we cannot say either it will change it or no, but it modify. Okay, to what level that it will decide. Very highly, deeply, maybe you can say very deep algorithms will be come into the picture at that time.
So what does it do, modulation? It increases the data transfer rate, or what does it do exactly, modulation?
So these modulations, what they do is they provide different data rates. Like, okay, let me just repeat again. Like I talked about three modulation thing. One was DSS, second was CCK, and third was OFDM. DSS, when I was saying in this kind of modulation technique, we can have either 1 Mbps or 2 Mbps rate. But in case of CCK, I was saying that it can go up to 5.5 or 11 Mbps rate only. Whereas for the newer version, like these all, even more than it, OFDM can able to handle.
Okay, so increases the data transfer rate.
In case of?
It increases the data transfer rate, is it? Okay. So it modulates the signal and increases the data transfer rate. Simple, right?
You can relate with that, right? It is a technology by which techniques by which we enable the transmission, and we enable the higher transmission probably, you can say, on the higher data rates.
Okay. So it modulates the signal and increases the data transfer rate. So that's it, simple.
Okay, let me tell you again. I am writing down here. Modulation technique. Okay. What it does, it maybe you can say enable the higher data transmission. How it does? By modifying the parameters. So it is what it does. It is how it does. Got this point?
Yeah. Okay, I got it. So it just increases the data transfer rate. That's all simple. From 1 to 2, it increases the data transfer rate, right? That's it. Modulates the signal. Modulates the signal and it will increase the data transfer rate. Simple. It will spread the signal. It will spread the signal to various destinations and increase the data transfer rate, right?
True. Now, let's proceed. So, have you heard about the term service set in the wireless?
No.
Okay, it's all right. Wireless communication, you already aware by now that it is done over radio frequency signals.
Yeah, electromagnetic signals.
Right. So all the communication, either it is sender, either it is receiver, both use the radio frequency only. And when, let us say, there is an AP and there is one, your client or station, both of them should be on same frequency or same channel to send and receive the data. And as I told you in our previous classes, that IEEE is an organization who define the technical standard for your 802.11 and so that your network vendors produce their product according to these standards. There is one more sorry. There is one more non-profit organization named as Wi-Fi Alliance. Okay. It's certified your wireless products so that the vendors are compatible with 802.11 standards defined by IEEE. So whatever your APs or whatever your things are, they will be Wi-Fi Alliance certified. One thing. Second thing, I was talking about that there are different wireless topology can exist. If you talk about, I need to send some data from my mobile to your mobile, I can simply give it to you over the Bluetooth or maybe some Wi-Fi direct or some kind of such kind of applications. Or we can say these are ad hoc network. So when such is the case, when you just, maybe through your laptop to PC or sorry, mobile or mobile to mobile or laptop to laptop, your wireless communication is still going on, no? That kind of communication where you don't need any kind of access point or something like that is named as IBSS. BSS stands for Basic Service Set. I stands for independent. So it will be independent basic service set.
What is this IBSS exactly?
Sorry?
What is this IBSS exactly? Doesn't use access point, is it?
IBSS, maybe you can say it is a topology. When we don't require the AP at all.
Okay, without the AP. Okay.
IBSS. Now,
Right.
when we
Because
need to expand
in my home, I have a wireless router, right? My home, right? That's IBSS, right? Because it's not using
that
wireless
is
access point.
basic service set.
Right. Without an access point.
Basic service set means there is a group of the devices which consist of central wireless source. So in your case, it will be modem. In companies, it can be AP. So it means 802.11 standard says there can be IBSS, there can be BSS, or there can be ESS also, that I will be going to explain in a moment. First, let me complete BSS. So the left hand side picture, what you see here is the BSS, basic service set. In case of basic service set, you have a central unit, as I told you, star topology. This central device can be AP or can be modem, as we were talking. And every BSS has a string, or you can say logical name of network, which is named as SSID. SSID. ID stands for identifier. SS service set. See, BSS service set identifier. SSID is clear?
So the BSS could be either it could be wireless access point and could be a wireless modem.
It can be, yeah, it can be modem also, right?
Right. So BSS is nothing but could be a wireless access point and could be a modem, because at home I have a wireless modem at home.
It is bit like you should have some central wireless source.
Right. Yeah. And because at home I have a wireless modem at home, right? Wireless router. So I get the wireless, right? So BSS is nothing but could be an access point and could be a wireless access or a wireless modem, right?
Right.
Right. Okay, got it.
Also, SSID is clear to you?
Yeah. It's the name of the network. Simple.
Name of the network. And there can be multiple SSID in your environment.
Yes. In my working environment in Honda, for example, they have about 2 or 3 SSIDs.
Yes. Even you can have same SSID name with 2.4 and 5 gigahertz of the range.
Right.
Okay.
Yes.
So let us say if there is a corporate user, you can have corporate SSID for them. If there is a guest user, you can have guest SSID for them.
Okay, excellent. Because in our environment in Honda, you have 2 SSIDs, one for employees, one for guest.
Correct.
Yeah.
Same.
Yeah.
Okay.
Yeah.
Now, as I am telling you, it is an identifier, and when you are using an identifier, when packet will get formed by this PC to your SSID, and if there are different SSID, the MAC address should be also somewhat differ from differ SSID. And there come one more thing named as BSSID. Are you getting my point? So BSSID is nothing. Maybe you can say that automatically different MAC address get created for different SSIDs. Probably in the lab, I will show you further, and you will able to understand more on. Okay.
So different MAC IDs for different SSIDs, huh?
Different MAC address.
MAC
address. See, when your frame will get created, you will have source IP, you will have destination IP, you should have source MAC, you should have destination MAC. Which MAC it should use? So different SSID, let us say SSID 1 have different MAC, SSID 2 have different MAC. These are BSSIDs. MAC of maybe you can say
different MAC addresses of your IP phones or your laptops, right?
In the lab you will understand more, right?
Yeah.
But
what happens is in the environment, the phone is connected to the switch and the laptop is connected to the IP phone, right?
I'm sorry.
The phone is connected to the switch, okay, and the laptop is connected to the phone, IP phone.
Okay.
Yeah. So the different MAC will be different MAC address of different laptops or mobile phones.
Right? Different SSID, different. Now all of your clients, let us say these clients, can communicate in your this. Can you see this area This is also named as basic service area, BSC. Okay. So in this cell or BSA, we can say it as cell or we can say it as area. Okay, basic service area. So all of the device in your BSS, okay, can communicate with each other. But what if they need to communicate with some of the device which is not connected with your AP? Then you need some kind of communication among them. And can you see this switch? This switch is named as DS in wireless technology, which is nothing but distribution system. Got this point?
Yes. Okay. So if it's not your own AP, could be an AP of another client, another organization, right?
No, they your organization only. Let us say organization ABC and ABC. But what about the client which are connected with the BSSB, BSSA? How they will interact with each other if they need to talk with each other? You can have a IP telephonic calls in between, right? You can do a chat in between. Lot of communication can be there. For that, you need to have some wired connectivity also. And when they are connected with some kind of switch or something, it is named as distributed system or DS. And all the VLAN configuration will be done here.
Okay. So you're saying that you have clients on one access point and client another access point with different SSIDs, right?
It can be different. It can be same also.
Okay.
Let us say this is guest SSID. This is NetMinion SSID. And if we wanted to have the communication between PC1 and PC3, these stations can talk with each other. If we don't want to apply any kind of, if we don't want explicitly that they should not communicate, that is a separate thing. But ideally, there should not be any issue.
Okay. So clients in one SSID can communicate with clients in other SSIDs through a switch. Am I right?
Right.
So you have SSID NetMinion and SSID guest, and both the different clients.
Let me tell you, access point has their own limitation. This access point can provide a range up to a level. Let us say after this level, if our sitting area is exceeding, then what? We had to provision another access point. And if one client is just moving from here to here, okay, this is something named as roaming, which we will be going to discuss later on. But in case of roaming, how the traffic will move? There can be the same SSID also provided by both of the APs. So this BSA, okay, this area, basic service area or cell is limited. Post that, maybe it's not capable enough to handle the data. So we need to apply more than one access point also for same organization as well.
Right. Yeah, access point is limited, right? Limited. Range is limited.
Access points are just used to cover all the area, maybe you can say.
Right.
But in that case, your access point will get connected to the Ethernet switch. Okay? Your access point will be having some port which will get connected with the switch.
Yes.
And this Ethernet switch, what I am talking about, okay, this is named as DS. And when you have such a scenario, it is named as extended service set, the third type, ESS. So I talked about BSS, I talked about BSS, and now I am talking about ESS. And our whole class will depend upon ESS. Is this point clear?
So IBSS is just within one range, is it?
What?
IBSS.
IBSS when we don't require any kind of AP.
Okay, you don't require an AP. Okay, and BSS when you require an AP, right?
AP. Only one AP maybe you can say.
Okay.
But when
So
you have
IBSS.
one AP
Okay. Okay.
and in your organization, it will be extended service set.
More than one AP.
Combination of two or more than two, APs.
So IBSS without AP, IBSS is one AP, and AS has got more than two APs.
Right.
I got it. Thanks.
Sure. If this part is clear, let me talk about one more point here, which is really makes sense, and you should be aware of about the same. That is, let us say if you have one AP, you are creating SSID here, okay, and everything is working fine. But if you have two APs, okay, then you need to create SSID here also, you need to create SSID here also. If you have 10 APs, you need to create SSID on all of the APs. Okay? Because AP can work in one of the two mode, which is autonomous AP, which means this kind of mode when you use in the AP, it is in charge of everything. It is a standalone management wireless controller type, you can say. It is a little controller, you can say, bit like your WLC. But when you have very bigger design, we cannot go with this approach. Because now AP is responsible for all of the things. What all of the things? Like, if some requests are coming, it will provide the approval of your association request. If, let us say, if this basic service set by default is this, but the limit is this, it means it need to transmit more. So transmitter maybe power management will be done by whom? Done by your AP. Then your radio frequency management, like it should be in channel number 1, it should be into channel number 6, and if you are applying some more, it should be into channel number 11, like that. Your RF management need to be done by whom? By the AP itself. And whatever maybe I can say, whatever your basic service set required, what all the management required, you need to do individually on every single AP. Getting my point? So this is the scenario, like you can say it is standalone access point or autonomous AP, which behave like WLC in its own, but not good for a bigger environment. Got this point?
Got it. So without wireless controller, you can do everything on autonomous AP.
We can work, right?
Right. So you don't need a WLC at all.
Yeah, we don't require. We can go with the standalone AP or the autonomous AP. Okay, but every VLAN you need to go. It should be the trunk port. It should be the trunk port because every VLAN should be allowed over here. But AP management really become very complex, and it is a tedious task for logging into every individual AP and doing all the stuff. let us say if there is some kind of firmware upgrade, you need to do individually on all of the devices. Getting my point?
So autonomous AP is nothing but a wireless controller, right?
Bit like, maybe you can say bit like.
Okay. So wireless autonomous AP they're using mostly they don't use autonomous AP, right? They use the wireless controllers, right? Most of the environments.
No. For okay, let me talk. So I talked about one of the mode for the AP, and though that mode is named as auto or standalone. Standalone AP. Standalone AP. This is one type. Second type is thin AP. It's also named as thick. Okay. Second is thin AP, or you can say LWAP, lightweight access point. Got this point? Lightweight access point. And when you have lightweight access point, it is named as lightweight because it does not carry any kind of configuration. Everything, it will depend upon the controller. These two modes are clear to you.
So everything is done with the access point configuration without a controller.
Controller, through the controller, yes. There are some stars which I will be gonna cover into today's class only. But yes, for now you can think about that. Yes, everything is configured by wireless controller.
So the autonomous standalone and the LWAP is done through the wireless controller, not
Right. So autonomous AP don't require controller.
Okay.
Controller, when there is controller and there are AP, it means they are working as LWAP. Got this point?
Okay. So autonomous standalone, we don't need a controller, but LWAP integrated with the controller, is it?
So later on, I would talk about that there are different images as well for the same model. If they are acting as a thin client or the thick client, different images are also. Okay.
Autonomous AP, don't have a controller. It's called thick client, and LWAP is a thin client, which is integrated with the access point with the controller.
Right. That is true.
Okay, thanks.
If this point is clear,
Yeah. What is the full form of LW? Lightweight access?
Lightweight access point.
Lightweight access point. Okay. So for lightweight access point, you don't need a controller at all, right?
That's true.
Yeah, it's integrated within the LWAP controller, right?
That's true.
Okay.
Now, let me talk about one more point here. Let us say when you are purchasing the APs for your environment. Okay. So okay, you need to do couple of the things. Like first, you need to do the capacity management. What does it mean? Let us say your company is going with some of the specific AP for 3800 series. Okay. Now, if that is maximum client, it can provide 25, 25 clients. Your total clients are 100. You are expecting in the office that 100 clients would be there, right? So what happen in such scenarios, because when there is an AP, okay, there is an AP, this is your basic service set, you cannot have another AP like this. If you will design like such a scenario, if somebody is coming here, okay, your network will get dropped, which is not a good design. So ideally, the good design is there should be some overlap between your AP1 and your AP2. Getting this point? How much overlap should be advised? If I will say overlap, how much overlap it should be? So it depends like what kind of data you are using. What I mean to say, let us say if you are using the network data, simple, network data, that is the TCP based, your overlap for these two APs can be less. But if you are using the voice or video data, then your overlap should be more. Why? Because that is UDP based. And your traffic, if get failed, it will be failed. It won't be sent again. Are you with me?
Yeah.
So that is the reason that when you are designing something, your capacity management should be very properly analyzed. Okay. So that is one point, capacity management. So let us say
So
if we have,
there should be no overlapping, right? Is it?
sorry,
There should be overlapping, right? There should be overlapping, right?
yeah, it's there should be overlapping, right? But how much,
Because
to which extent, that we can decide based upon your data or voice traffic, like what kind of traffic you are having.
because if you don't have overlapping, then the signal you might lose the signal, right?
Yeah, in case of roaming, there would be black hole.
Right. Because if there is some space between one AP to other AP, and it could if we move, and it could lose a signal, right? If you roam from
Yeah,
one AP to another AP, if there's not
yeah,
overlapping, there is no space in between. There is a space in between the two access points, then you could drop the signal, right?
true.
Right. So you need to have overlapping. Okay, all the access points should have overlapping so that there's no loss of signal, right?
There is less loss of signal, or there is seamless roaming.
Seamless roaming, yeah. That
Okay.
is called capacity management, eh? Overlapping. You should have
Ah,
overlapping access points. That's
ah,
called capacity management. Okay.
right.
Okay. Thanks.
So you can say 10 to 15%. Okay. You can say 10 to 15% for your, it should be for your data because it is your TCP thing. But when it comes to your voice, it should be at least your 15 to 20%. Right? So when you see, when you log in onto your laptop, right, you see some bar. You see
Yeah.
some, you
On the
see some bar.
on the bottom, yeah, you get the wireless connector, yeah.
Right. When you go for the wireless. So that bar should not be less. Okay. Number of bars are more, it means your signal is strong.
Strong.
So signal, let us say if you have minus 60 to minus 70 dB of the signal, it means you have 5 bar. Good signal. But if it decreased more than that, like 70 to minus 80, let us say you have only 3 bars. Okay. So your RSSI value should be good. Are you getting my point?
Yeah.
So these are the stuff you need to be taken into the consideration whenever you are designing your network. One is the capacity planning, what I was describing.
Yes. There should be overlapping. There should be.
Right.
Right?
Right. So capacity planning, if one AP is able to handle 25 of the clients, we should consider 20 clients because there would be overlapping also. And if total 100 clients are there in our office, we should select as 5 APs in that case.
Mm-hmm.
Got this point?
Yeah, yeah.
So capacity planning is okay for you, right?
Yeah, yeah, yeah. So you should have overlapping, okay, and more access points for more coverage, right?
Right.
Right.
Second point, switch port
Mm-hmm.
availability.
Mm-hmm. Mm-hmm.
So whenever you have the ESS, there should be a DS,
Mm-hmm.
and that DS should have switch port available.
Mm-hmm.
Getting my point?
Mm-hmm.
If you don't have the switch port available, it
Mm-hmm.
means you cannot, where you will plug your AP to get it connected to the wired network.
Mm-hmm.
It is absolutely necessary to have the specific interface available.
Mm-hmm.
So whenever you are designing, you need to think about switch port availability point also. Getting my point?
Yes, yes.
Third, whenever you are booting up your AP, this
Mm-hmm.
AP, it required a power injector.
Mm-hmm.
No.
Mm-hmm.
So I am saying AP power resource. Why? Because if your switch is PoE, power over Ethernet, right?
Mm-hmm.
How you can check? By issuing the command show power inline.
Mm-hmm.
So if your switch port can provide the power, that is fine. If your access point is also supporting PoE and your switch is also providing PoE, that's fine.
Mm-hmm.
Otherwise, you required an external power.
Mm-hmm.
Got this point?
Yeah, yeah, yeah. Okay. So the command to see if it's PoE has got show power inline, is it?
Show power inline. Yep, yep, yep.
Okay. Can you show it to me during the lab time?
It would be the switch thing. So maybe I will show you. Don't worry. I will show you. Okay.
Okay.
Fourth, license.
Mm-hmm.
You should be aware your WLC has the license into this. Okay. And license for different what is it? What different WLCs can contain or different license can contain different number of APs.
Mm-hmm.
Let us say if your WLC can go till 200 AP, you
Mm-hmm.
if you are planning for one more AP, you cannot do that. Why? Because your number of license is full. Getting this point?
Yes, yes.
Yes or no?
Yeah, 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 yes, yes, yes. Got it.
So when you log in onto your wireless, it show you 200 AP supported. Or through the CLI, when you log in into your CLI of your WLC, you can issue a command show license
Mm-hmm.
license summary.
Mm-hmm. Mm-hmm.
And if there is an evaluation license available, you
Mm-hmm.
can accept that evaluation license by activating that. You can just put the command license
Mm-hmm.
activate
Mm-hmm. Mm-hmm.
AP count
Mm-hmm.
for evaluation, and just
Mm-hmm.
you it will ask yes or no. You put yes and it will get accepted. These 4 points are clear to you. Am I audible?
Yes, yes, yes.
Okay, these 4 points are clear.
Yeah, yes, yes, yes.
Now let's talk about the fifth point, that is regulatory domains.
Mm-hmm.
See, what happened is there are different regulatory domains as per different country available. So
Mm-hmm.
be cautious whenever you are raising some kind of purchase order, PO.
Mm-hmm.
You should see that what is your regulatory domain, and you need to purchase the like AP as per that. Let me show you. Maybe give me a minute.
Mm-hmm.
Let me. So go to the Google, okay,
Mm-hmm.
and
Mm-hmm.
here maybe let me search for wireless LAN um,
Mm-hmm.
compliance lookup.
Mm-hmm.
Okay,
Mm-hmm.
go to this wireless LAN compliance lookup.
Mm-hmm.
So see, it is showing you regulatory domain. For this country is minus E. For this country is minus E. Okay. For Algeria is minus I.
Mm-hmm.
Row also for the indoor for this specific thing.
Mm-hmm.
So depending upon different model, you can see here different regulatory domain are there. Let me select for India. Let me see what is for the India. Okay.
Mm-hmm.
So India. If I select India,
Mm-hmm.
which access point, indoor or outdoor? Let us say indoor. Okay, maybe let me select any. Huh? Can you see regulatory domain for the India is minus D.
Okay.
So your regulatory domain is one of the thing which is important when you are raising any kind of PO purchase order.
Mm-hmm.
Got this point?
Yeah, yeah, yeah. So for each
This
country, you got a different regulatory domain. Huh?
I'm sorry.
Each country got a different regulatory domain. Each country.
That's true. That's true. So that is one thing when you are designing your or deploying your APs into your environment, you need to
Mm-hmm.
consider about these all points.
Mm-hmm.
Any doubt?
No problem.
So we talked about IBSS, we talked about BSS, we talked about ESS, we talked about the capacity management. I hope
Right.
all of these fundamentals are clear to you, right?
Right. So IBSS is without a access point, BSS with one access point, and ESS more than one access point.
Correct. Correct. Now I need to talk more about your lightweight APs. Okay.
Mm-hmm. Mm-hmm.
Please try to understand it is really very important things now which are starting up.
Mm-hmm.
So it whenever you have autonomous APs, let us say there are many things you need to consider before deploying the multiple autonomous APs in your area.
Mm-hmm.
Because administrator must need to manage the area by working like let us say transmitting power to avoid overlapping, or let us say the channel interface prevention that he need to go and need to make the channels thing by their own. Scalability, if it's very getting it's getting scale like it's getting spreading up more, then in that case also you need to have more autonomous AP, and again for that autonomous AP your support thing is really very hectic.
Mm-hmm.
So your autonomous AP architecture
Mm-hmm.
is like scaling is possible, but very complicated, right?
Mm-hmm.
So that is the reason we use lightweight APs. Lightweight APs.
Mm-hmm.
Okay. When we are using lightweight AP, we are not using autonomous AP architecture, but
Mm-hmm.
we are using some architecture which is named as split MAC. So
Mm-hmm.
architecture is split MAC architecture.
Mm-hmm.
Is this fine?
Mm-hmm.
Why we call split MAC architecture? Because the reason is it split the functions.
Mm-hmm.
Some function will go with AP, some
Mm-hmm.
function will go with WLCs. not the complete.
Mhm.
So it split the function between your controller and your LWAPs, lightweight APs. Now, if I will talk about which function to what, right?
Mhm.
So I will tell you, it will, it split the function as such that controller will pick up non-time sensitive um, non-time sensitive functions, okay,
Mhm.
like
Mhm.
authentication will
Mhm.
be done on controller, like association will be done
Mhm.
on controller, like reassociation will be done on controller, roaming or bridging will be taken care by controller.
Mhm.
Lightweight access point LWAP, okay,
Mhm.
will use the real time thing like what? Like FEH,
Mhm.
frame exchange handshake between the
Mhm.
client and between the AP. It will be your exchange will be done. No,
Mhm.
like collecting the signal information. If it need to collect the signal information for neighboring AP or bit like that, who will do that?
Mhm.
Your AP will do that. It will monitor that. It has the monitoring radio channels for the rogue APs for the encryption and decryption of your 802.11 frame. So that
Mhm.
all functions will go to whom? To your lightweight APs.
Mhm. Mhm.
Is this point clear?
Mhm. Can you explain to me again? Sorry.
What the complete?
Yeah. Just yeah. What were you saying again? Sorry.
So what I was saying is that your
Mhm.
function got split down.
Mhm.
It has the non-sensitive, non-time sensitive, it has the time sensitive. All the functions are split down.
Mhm.
So AP has picked couple of the functions and
Mhm.
WLC picked up on couple of the functions. So
Mhm.
your LWAP, when you are using your lightweight access point mode, they
Mhm.
depend upon WLC for the management task.
Mhm.
And this is again your ESS.
Mhm.
Any doubts so far?
Okay. So the LWAP is splitting the task, is it? Something like that?
Right. LWAP has the splitting the task between the controller and the AP. Because if you talk about the autonomous AP,
Mhm.
everything is done by whom? By autonomous AP itself.
Mhm.
That architecture is also can be said as local MAC architecture.
Mhm. Mhm.
But here the function are divided between the APs and between the WLC. It is divided. That is the reason it is named as split MAC architecture.
Okay. So the communication is split between the AP and the controller, is it?
Right. You will understand more. Okay, wait for a minute. You will
Okay.
get more detail about it. But it's a just starting. What I am trying to, give you an overview. So first two
Mhm.
classes are just for the theory. Then we will
Mhm.
pick up the speed for the practical, right?
Oh, okay.
So these are very basic fundamentals, but very important for your wireless class.
Okay. So split MAC is it splits the data communication between the lightweight access point and the controller.
Split MAC architecture, which means it is splitting the function between your WLC and between your AP.
Okay.
So all of these are AP, lightweight access point, you can see.
Mm. Now all these LWAPs, they had controllers embedded into it, or is this an access point?
So these all are the AP. Here, if you see, these all are the AP. They are connected to the access layer. You can see this is
Right.
the access layer. Okay.
Right. Right.
Access
Right.
layer going to the distribution, the
Right.
right, and then they are going to the core. And on the
Right.
core, we have WLC connected.
Right. See, in our environment in Honda, they have 5500 series, 9800 series wireless controllers, and it's all connected to the core switch.
Yes,
Yeah.
yes. And the reason is because your WLC will receive all the traffic, no?
Yeah.
So it
So
should
they
not
have like
it should not
primary. They
connect
have
to the
like
access layer.
two controllers. They have one primary and one standby in our environment.
Right, right. There can be multiple controller, but for this diagram, I just uses one controller because these are the previous classes, right? During the roaming, we will see more controller.
Okay.
Okay.
Okay. And autonomous APS is an access point with a wireless controller embedded into it. Simple, right?
Without controller,
Without control. Yeah.
it will not have any.
Right. You don't need a wireless controller if you have an autonomous AP. Everything is in the AP itself.
Right. For autonomous, you don't know. But for this lab,
Mm.
lightweight access point,
Mm.
which you can see here, all the
Mm.
labs are there, right?
Mm.
For
Mm.
your labs, you required a WS.
Controller. Got it. Thanks.
Clear?
Mm. Yeah.
Now try to understand one more thing. That is, you can see here, CAPWAP, CAP,
Mm-hmm. Mm-hmm.
which stand for control
Mm-hmm.
and provisioning.
Mm-hmm.
Wireless access point.
Mm-hmm.
Control and provisioning wireless access points. CAPWAP.
Mm-hmm.
CAPWAP is an open protocol to help the WLC to manage all the wireless lab, which means with every lab, there will be a tunnel get formed with the WLC.
Mm-hmm.
So every access point will be having a tunnel with WLC. Okay,
Mm-hmm.
there will be a tunnel. And this tunnel is named as CAPWAP tunnel.
Mm-hmm.
Got this point?
Mm-hmm. A virtual tunnel or physical virtual tunnel, right? Virtual.
But yeah,
Virtual tunnel.
uh,
Okay.
this would be the virtual tunnel. Any doubt?
No problem.
So your wireless network of FWLC going to have two CAPWAP tunnels with APs, every single AP.
Mm-hmm.
Okay.
Mm-hmm.
Maybe before that, I wanted to tell you one more thing.
Mm-hmm.
Wireless network of your WLC going to the lab two CAPWAP tunnel that I talked. Okay. This
Mm-hmm.
is control tunnel and the data tunnel, respectively.
Mm-hmm.
Okay. And what
Mm-hmm.
happened is the requirement is that your lightweight AP should have the connectivity with your management. Sorry, should have the connectivity with your management of WLC. Okay.
Mm-hmm.
So this CAPWAP tunnel is responsible for CAPWAP control message,
Mm-hmm.
which is
Mm-hmm.
control CAPWAP tunnel.
Mm-hmm.
But if it is data, that will be responsible for data packets.
Mm-hmm.
Control packets like when you need to do some kind of configuration or something like that. Okay.
Mm-hmm. Mm-hmm.
So when you are having the control tunnel, it will use the UDP 5246 port.
Mm-hmm.
Okay. and it is an encrypted. Has all the encryption available, okay, so that your corresponding LAP will be only have one, like it is connecting to the respective WLC, and all the data traffic is encrypted. This is your DTLS thing, Datagram Transport Layer Security. Second tunnel, which come for your data traffic traveling to and from the wireless client to the WLC, is named as CAPWAP data tunnel. The packets here are optionally encrypted. For the data CAPWAP. Because couple of the countries don't support it, like Russia. And it uses another port which is UDP 5427. Any doubt?
No problem. So it's encrypted. Yeah, virtual tunnel is encrypted with UDP 5246. Simple, right?
So control tunnel is encrypted. Data tunnel is optionally encrypted. It may or may not, depending upon in which country you are running it.
Okay. So the control plane is encrypted and data plane is optionally encrypted.
Optionally. Yeah.
Okay. So
Now,
everything goes through the virtual tunnel. If wireless access point wants to communicate with the WLC, it goes through the virtual tunnel.
right. So it will bit like this.
Right.
Every access point will have a tunnel associated.
Okay. So all the access points will get connected to the
Will
controller through
form a tunnel.
virtual
Yes.
tunnel, and within that virtual tunnel, you have a data plane and control plane. Control plane is encrypted. Okay.
That's
Right? And data plane is optional encrypted, and control plane is encrypted. So you have a virtual tunnel basically between the laptop to the WLC. That's how it communicates, right?
that's true. Yes.
Right. Because the wireless access point has to communicate with the controller, right? How will it control, right? So it needs a tunnel, right?
Right.
Yeah.
So far, any doubt?
No problem.
Okay. Now, let us say if we are talking about the cloud infrastructure, cloud-based. So in cloud-based, all the APs will work as the autonomous only. But you can configure the AP easier because your management process for all of those things will go to the cloud-based AP architecture. Like if you talk about Cisco Meraki, okay, then they like there would be AP autonomous AP architecture, but scaling is possible through your Meraki controllers. Cloud-based wireless architecture, it is named as. Got this point?
Yeah.
So your management task of the AP is moved to the cloud.
Okay. So instead of hosting it on the on-premises, it's hosted in the cloud. Simple access in the cloud, right?
See, on premises, if you are aware, like there can be Cisco Prime infrastructure also. You can have Cisco Prime or Cisco DNA, right? So these all things you can adopt for, but as of now, what we are discussing is controller, wireless controller. Are you aware that there is 3850 series of switch is there?
Yeah. We have 3050, 4500 series. In our environment in Honda, they have 3050 and 4500 series of switches. Both.
Let me tell you, this switch is, has the wireless capability also. It can act as a WLC with support of 50 access point or 2000 wireless clients. Even 802.11 AC can be, standard or allow throughput is there for 500 Mbps per link.
Okay.
For total 400 Gbps wireless throughput can be there. But see, the CAT OS are now going for in the newer like wireless thing. If you talk about the 9800, okay, that is also supporting the CAT. Any doubt?
No problem.
Fine. Let's move. CAPWAP is also clear, na?
Yeah.
So in Cisco, if you will talk now, what we were talking about, you can have couple of the designs available. Okay. So like earlier, I was showing you everything was making the CAPWAP tunnel and everything. Centralized network design, where all the APs, okay, are connected with your WLC. So in other words, we can say that it is local design in the wireless case of thing, when where your WLAN controller is there and access point are there on the same side. So these controllers, these are the controllers which is acting as the centralized wireless design solution and really ideal solution. Okay. And you can place your Cisco 5500 series, 3800 series of the controller, 3500 if you have the small, organization. So it is like well used when your all the devices like controller and your all of the access points are in the same site. But let us say if you have a small site, okay, there is a small site and there is only handful AP, AP or one AP. You cannot place WLC here. Rather than this AP will send the traffic to the WLC which is sitting on another location. Maybe it is EU, it is a PAC site. At that time, you cannot have this centralized approach. What you can use is somewhat named as Flex Connect design. So Flex Connect is a wireless solution for your branch office, or maybe you can say for your remote office deployment. As it enable customer to configure and control your access point in a branch from the corporate office or maybe from other, office, which is the headquarter, through your WAN link. So Flex Connect access point can switch the client traffic locally. Later on, I will show you how. Otherwise, if it is not in the Flex Connect, it will go to the WLC to have all the decisions. But in Flex Connect, it can perform the local authentication. It can do couple of the things locally. Getting this point? So we can use Flex Connect mode also. Then there is one more mode that is not required to be discussed here, out of scope. But yeah, we can use that, named as SDA design. But obvious, as you see, SDA, it means it is an integrated solution to your SD access wire design. You should have VXLAN data path, fabric APIs, fabric control plane, okay, everything like that.
So in Flex Connect, you have WLC across the wireless, across the WAN.
Across the WAN, yeah.
Okay, so you don't have a centralized WLC in the premises,
Right.
So you have a WLC across the WAN, could be in the data center, right? Because when I was working with Walmart, they had control in the data center.
Correct.
It's across the WAN, right? So you find working from the office in Mississauga, it goes to the data center, right? Across the WAN, right?
Now, What is the use of WLC? You will able to understand by understanding the RRM. Have you heard about this RRM feature in WLC?
No, I'm not talking
RRM means radio
about.
resource
Mm-hmm.
management.
Mm-hmm.
Okay,
Mm-hmm.
let me talk some of the brief history about the RRM.
Mm-hmm.
See, in today's class, I am just giving you the overview, right? There are a lot
Mm-hmm.
of things which exist, but we will be keep on, explaining them when we will have a deep dive, right? Using
Okay.
the lab also.
Mm-hmm. Mm-hmm.
But these are the building blocks you should aware of.
Mm-hmm.
So RRM was introduced originally by, it is as a feature by a company named as Airspace. Heard
Mm-hmm.
about it?
I don't know. Not sure.
Airspace was merged into or acquisite into the Cisco, okay,
Mm-hmm.
back in 2005.
Mm-hmm. Mm-hmm.
Airspace was a company, okay. Formerly, it was named as Blackstone
Mm-hmm.
Networks.
Mm-hmm.
Was a networking hardware company founded in 2001, which manufacture your wireless access point and controller.
Mm-hmm.
And this was the company developed the AP controller model for fast development and the lightweight access point. Okay,
Mm-hmm.
and the
Mm-hmm.
what I was talking about, light access point protocol. It is the predecessor of your CAPWAP.
Mm-hmm. Mm-hmm.
So this was the layer two thing,
Mm-hmm.
and CAPWAP layer is your layer three thing.
Mm-hmm.
Got this point?
Mm-hmm.
Now, if we talk about the radio resource management or RRM,
Mm-hmm.
we can say nowadays, if you just ask what is RRM, I will say it is really a very crucial feature
Mm-hmm.
of your wireless LAN controller or WLC,
Mm-hmm.
which play a vital role in optimizing the performance and the efficiency of your wireless network.
Mm-hmm.
And by default, it is enabled on your device.
Mm-hmm.
And it does self auto radio frequency things.
Mm-hmm.
So this RRM is responsible for managing various of the aspects for your
Mm-hmm.
radio spectrum.
Mm-hmm.
Maybe you can talk about channel assignment, power level, maybe interference mitigation.
Mm-hmm.
Everything will be handled by your RRM. So
Mm-hmm.
Cisco implementation of RRM is designed to automate your these tasks to make it very simpler and best possible solution for your wireless network performance.
Mm-hmm.
RRM is what? Collection of algorithm, maybe you can say,
Mm-hmm.
which together provide a very comprehensive management solution.
Okay. Is there like a feature on the wireless controller, like a feature on them? Like, is it on the wireless controller itself, like some kind of like a command or something?
Mhm. Now, when you have RRM, okay, later on you will understand more about it, but just I am giving you an overview. RRM has couple of the hierarchy.
Mm-hmm.
It will be having an RF group.
Mm-hmm. Mm-hmm.
All WLC's APs should be the part of that RF group.
Mm-hmm. Mm-hmm.
Okay.
Mm-hmm.
When you have a group, you should have a RF group name also. So
Mm-hmm.
RF group is nothing, but you can say it is a logical container that an instance of RRM is configured through. And all devices belonging to the single RF network will be configured as the member of that particular RF group.
Mm-hmm.
So for any group name, multiple RF group leader can exist. So second thing is RF leader. So leader will be get automatically selected, or manually also we can do it by the configuration. Two leaders are at least required. One for 2.4 and one for the 5 gigahertz. Okay. Then the third thing, RF neighborhood. RF neighborhood means a group of AP that belong to the same RF group, which can hear each other, maybe at minus 80 dBm at least. So this is physical grouping based on RF proximity. So that is how maybe I will say what was the brief history of RF. Now, what it does. Okay, if I will talk about what it does, there are lot of things which your RRM does, and you will understand the concept why WLC is required. You will get that point. Let me talk about one point, DCA, dynamic channel assignment. RRM uses your DCA to automatically select the best channel for your access point based upon your different RF conditions. So if you have this access point A and you have this access point B, can you keep into the same channel? Yes or no?
We can, yeah.
No, we should not. Otherwise, it will interfere. So if it is using channel 1, probably we will go with 6. We will go with 11. Then we will go with 1. And if there are 100 of access points, who will do these channel assignments? This feature, this algorithm. It continuously monitor the radio environment for the interference and adjust your channel assignment accordingly to minimize the interference and optimize the network capacity to its full usage. DCA, understand? Yes or no?
Okay, I got it. So the RRM will do the DC channel assignment to various APs and controllers.
This is the one feature I told you. Let me talk about second feature. TPC. So transmit power control. Again, it will be dynamic thing when you are using your WLC through the RRM. So what does it mean? AP has a cell I talked about, that is BSA, right? If there is a client very nearby, you need to increase little bit more power. No? So it RRM on behalf of you. If you have autonomous AP, you will do this. But if you have the WLC, it automatically adjusts the transmit power level of AP to ensure optimal coverage and minimum interference again. It can increase or decrease the power level as needed to maintain your stable RF environment. Any doubt?
Okay. Power level, is it?
TPC.
What is it again? TPC? What's the full form of it?
Transmit power control.
Okay. What does it do exactly?
Transmit power control. Every of your AP has some kind of power. No.
Internal power. There's no wired power, right? Internal power, right?
Sorry?
Within the AP, you have a wired power, or internally you got a power inside the AP?
No, I'm talking about the signal power here.
No, what I'm saying is, for AP, for the power supply for the AP,
That's
it
all
has
right.
got.
See, AP has a power supply which boot up the AP. I'm not talking about that.
Hmm, hmm,
What I am talking about is the signal power. Like this AP can transmit the signal till what level? If this is the
mhm,
AP, all the
mhm,
clients inside into this area can have the wireless connectivity. Why? Because it falls under the basic service area, or this is the AP cell. But
mhm,
what if you wanted to increase the cell? Then you need to increase the power transmission, radio
mhm,
wave power,
mhm,
amplitude,
mhm,
signal strength. Getting my point?
mhm, mhm,
And that transmission of power control is done by whom? By uh,
okay. This signal strength and all that. Power
yeah,
control,
yep,
signal strength, range,
yeah,
coverage,
yes. So
order
that
my
is named as TPC, transmit power control.
okay. So the range, the coverage, the range,
Please go through
and
this video again. You will understand more.
okay. So the DCA will dynamically allocate the channels to the AP. Yeah?
Dynamic channel assignment. Yes,
So these APKs then communicate on one channel, right?
that's true. You
Okay.
have different
All
different
the
channels.
APs will communicate on different channels, right?
It should be because of less interference.
Right, right. Because if you're in the same channel, then it's going to have more interference, right?
Yeah.
Right. So what happened is all the APs works on different channels. Okay.
Right.
Right? I think in 2.4 gigahertz you have 11 channels, right? And 5 gigahertz you
Yes,
have
14
32
channels
channels.
actually, but for the usage in maximum countries, you can say 11. And non-overlapping are only three, 1, 6, and 8.
Okay. Okay. So you have lapping 11 channels for 2.4 and 22 channels for 5 gigahertz, right?
True.
And all the access points will work on its own different channels, because if you have the same channel assignment to the access points to the controller, then it's going to be interference, right?
True.
Right. So all the access points has to work on a separate channel, not the same
Channel.
channel, because if they're working in the same channel, that could be interference of these signals,
There will
right?
be, this is the poorest design because it
Right.
is, you know, all the interference we have.
Right. So all the APs have to have a different channels to communicate. Okay.
Mm-hmm.
Am I right?